Well, this is an update on the compressor. Since my last video, I have installed the motor and I have re-drilled the mounting holes for the motor mounts. I installed the pulley. I replumbed the discharge tube. I installed a check valve. I installed a new liquid-filled gauge, and I replumbed where the switch was installed, because with the check valve, the switch wouldn't be reading tank pressure in the old location, and then I've got an unloader included in this valve. Now, the reason why I haven't posted an update before now has to do a lot with this pulley right here. So, to give you some idea of what the problem is, this is a 10 horsepower motor, and this compressor is rated at 35 CFM from the factory. Now, at 35 CFM, you've got a 19.25 inch pitch diameter on this pulley, and you've got an 10.4 or 10.6 inch pitch diameter on the driving pulley. Now, that actually overdrives the pump by about 50 RPM, raising the CFM from 33 and some change to 35 CFM. Now, that in itself isn't particularly important, other than the fact that this compressor is designed for a 200 amp feed service, so it'll draw 208 amps full load during start if you have contactor attached to the motor and it does a cross the line start. The problem that I'm running into with the VFD I have is that during startup, the compressor is drawing too much current. Let me demonstrate here. When this rotates around and the big cylinder is on top dead center, well, whenever it goes to bottom dead center and it starts compressing, there's a resistance right here. And the problem is that there really isn't enough volume on the compressor or on the discharge tube to really be effective, to overcome the torque required to start this. And the unloader valve, this unloader valve is not designed for startup. It's designed for recirculating while it's running. So, because there isn't a centrifugal unloader and the unloader is not designed for startup, the compressor basically starts with a full head directly against tank pressure, and that requires a substantial amount of torque. So what I have purchased is a 7.8 inch pitch diameter pulley off of eBay. Now, this pulley right here apparently is not real common anymore. They don't use C-section belts in industry. This is a C96 belt. The belt is 7/8 of an inch wide, and the belt is 100 inches long. And because they don't use these belts, these pulleys right here are rather expensive. I was able to find a new old stock pulley that is small enough to do what I need to do. My hope is that by going from a 1.8 to 1 ratio to I think it was a 2.3 or 2.5 to 1, that I'll have enough torque generate, enough reduction in the drive that the torque generated by the motor and the VFD at startup will be sufficient to start even when the tank pressure is at 95 psi. So the workaround, if that doesn't work, I have one further workaround, and that is actually to do a little bit of a hack to this unloader. So as long as you have somewhere around 30 to 50 psi of air in the tank, if you pop this valve manually, the unloader will actuate the recirculating unloader valves. So what I could do is, with the combination of the VFD, I could put a valve on here. Let me go to the other side so you can see. Sorry for the shaky cam. What I can do is basically I can put a valve that bypasses from the inlet of this unloader to the outlet. So basically I would have to put another T in here, and then I would attach this to another T. So it would go to here, and then it would also go to a valve. And the valve would be actuated by the VFD. So what would happen is I'd program the VFD so that it would turn the solenoid on when the VFD was commanded to run, and it would turn the solenoid off once it got an at speed signal. And what that means is that, say I have, with this setup to run the original RPM, I'd be running somewhere around 75 hertz frequency into the motor. So what I would do is I'd program the VFD so that the valve would open up whenever this switch told the VFD to run. And what that would do is it would send air to the unloader valves, which would completely bypass all the air running through the system. And it would reduce the amount of startup torque required. And the valve itself would turn off when the VFD was at speed. So if the commanded speed is 75 hertz, once it accelerated up to 75 hertz, it would turn the valve off, and then the compressor would start pumping again. So that's an alternative they have. But before really trying to get exotic with hacks like that, I figured I would just try running a smaller pulley, because if I run a smaller pulley, you're talking about another three-quarter to one reduction, which should reduce the amount of startup torque considerably. And because I have a VFD, I can simply run this motor at a higher frequency to get the same original performance. But the other advantage is because I have a VFD, I can run the motor at a lower speed. So, for instance, if I'm just using this as a normal compressor, it pumps up to 125 psi, and at full speed it runs 35 CFM. But let's say I don't want 35 CFM, I could run this at, say, 25 CFM, and it will put less wear and tear on the pump because the pump will spin slower. And if I need to do any sandblasting or something like that, I can go and do a manual override on it, and it will run continuously. I just tell it, okay, well, run the pump, at this speed continuously, and then what'll happen is this valve will be overridden. It'll shut off. They'll have a little tiny bleed out of that hole right there, and then this unloader valve will actually control the compressor itself. So I have a variety of operating modes. I'll cover all of that once I actually get the compressor 100% working. But as it sits right now, I've got everything. I've got all my plumbing done. I've got my check valve and unloader and my new compressor valve. This is actually adjusted to shut off almost exactly at the same time as this, and they're both a 30 psi span. So this shuts off at 125 psi, and then this goes into bypass just a half second later. So I got those timed pretty well. And the next step after getting that pulley on there and testing it to make sure it works is to either obtain or build a box to put the VFD in, so that I can have everything terminated to the box with strain relief and weather resistance. So, well, thanks for watching. I know this is not the best cinematography to date, but I just wanted to give an update on the compressor. I haven't forgot about it, and I've been working on this thing a couple times a week and just waiting on parts. So, thanks for watching. Bye.